Hello everyone. Recall the last lecture. We started with the data link layer. The data link layer is divided into two parts. That is, upper portion is logic link control and the lower portion is media access control. So last time only I told you that media access control and related Mac technologies will be covered in next semester or next year in your computer networks and security subject. So as far as your ITCCN syllabus is concerned, LLC is there in your syllabus. So the upper part of data link layer is nothing but logic link control. So what are the function of this logic link control? Framing, flow control, data error detection and correction. So last time this framing techniques we have covered. So framing, okay, as I told you that whenever a bit streams, okay, they are coming from physical layer to data link layer, you have to break that stream into frame. So that is called as framing technique. So framing technique, character count, fixed size framing, variable size framing. So character count and fixed size framing, it's not there in our syllabus. So variable size framing, it's there in our syllabus, where this character oriented protocol and bit oriented protocol last time we have seen, in which byte stuffing technique and bit stuffing techniques are dominantly used, okay, for framing technique. So basically LLC deals with framing, flow control and error control. So for last lecture we have covered this framing technique, in which we covered character stuffing and bit stuffing technique. So now for LLC, the two different techniques are remaining, or two applications are remaining. They are nothing but flow control and error control. Flow control and error control. So one by one we will see what is flow control and error control. Now if you see this figure, okay, the moment you look at this figure, you will understand what exactly the flow control is. See this, I'm taking a very simple example for this flow control. One machine is there which is operating at 10 gigahertz processor, and another machine having 1 gigahertz processor. So let us say if I want to transfer a 10 GB of data from this 100 gigahertz processor machine to a machine who deals with 1 gigahertz processor, then what is going to happen? There will be definitely a dumping of data from the high speed machine to a low speed machine, and probability of data loss is more. So that is what may can happen, or that may can happen if you are dealing with the high speed processor and low speed processor, if you want to have a data communication without flow control. So what is this? Flow control is done to prevent the receiver from being overwhelmed with the data. 100 gigahertz processor speed may overwhelm the 1 gigahertz processor system, and a data loss can be occurred, and that's why the flow control is must. What exactly it is happening? Why this slow processor will not be able to synchronize with this high speed processor? Because whenever a data is being transmitted or being sent from this high speed processor towards low speed processor, different functions the low speed processor has to carry out. For example, this receiver has to perform a storing of data in the buffer. Thereafter, checking of data for the errors in the buffers. Then processing, that is if data error or correction is there, and then forwarding this data to the upper layer from the buffer. So these are the functions processor is going to do as its own speed. But the 100 gigahertz processor will not wait for that. The moment the data is available at its upper layer, it is going to dump the data if the flow control is not established. That's why the high speed processor data may overwhelm the slow speed processor system, and to avoid this, a flow control establishment is a must. That today we are going to see. The second point is the errors due to improper flow control are reduced and recovered through data error detection and correction mechanism. So how we will see? So types of errors. isolated and bursty errors. This is just to revise. You are aware of all these types of things. This is just to revise. Sources of errors. So error, different sources are there. Impulse noise, thermal noise, crosstalk. So impulse noise spikes man-made vehicles. Crosstalk, electromagnetic radiation due to adjacent wires, NEXT, FEXT, crosstalk, RF interference, and so on. Then error control mechanisms are echo checking. Okay, it occurs when source is intelligent. Okay, so such type of things you are already aware of. Okay, then forward error correction. So as far as this ITCCN subject is concerned, first 4 units are based on this forward error correction. So we have already seen this FEC techniques. Then next is automatic repeat request. So ARK techniques can be classified as for noiseless channel and for noisy channel. So just try to recall FEC and ARQ. FEC, where it is used, first 4 units of ITCCN subject, they are dealing with forward error correction. For one-way networks with long round-trip delays for point-to multi-point architectures, FEC is a better solution. So one to all, that is whenever you want to broadcast, a digital broadcasting is there, then this FEC and related coding techniques are very important. But instead of that, if it is one-to-one, ARQ, that is automatic repeat request, works best for the system that support bidirectional communication and that have low delays and error rates. So definitely this ARQ technique is going to be proven better. That's why we are going to use this ARQ flow control, data error detection and correction technique for our data communication. ARQ technique is divided into or classified in two forms: for noiseless channel and number two for noisy channel. Noiseless in the sense less traffic flow, less network congestion, or almost zero network traffic. And as far as noisy channel is concerned, the network traffic is huge. Okay, so the different techniques are being employed or you have to study. So let us say for noiseless channel, you have simplest protocol and stop and wait protocol. And as far as noisy channel is concerned, there are three techniques: stop and wait ARQ, go back in ARQ, and selective repeat ARQ. Thus, error control in the data link layer is based on automatic repeat request, which is the retransmission of data. So for noiseless and noisy channel, we will see one by one these 5 techniques in today's session. So just see this simplest protocol. There is a sender, there is a receiver. If the data is available, it will request a frame to be transmitted. So frame 0 transmitted, frame 0 received. So it is arrival at another end. Frame 1 transmitted, frame 1 received. Frame 2 transmitted, frame 2 received. This protocol has no flow control and error control. So it is very simple, will work for noiseless channel. Request is from network layer for task. Okay, and arrival is a notification from the physical layer of task, that is receive. So this is a sending process and this is what the receive process. So this is what simplest protocol. So there is no acknowledgement, there is no piggybacking, that is there is no control information with the data which is to be sent. So all these things, the basic indication of data is transmitted, received, data is transmitted, it is received, data is transmitted, it is received, but there is no acknowledgement, there is no reverse checking whether the data has reached or not, there are no acknowledgement. So it's as good as open control system. This is called a simplest protocol. Nobody is using this, but this is just to tell you that from simplest protocol we are going towards stop and wait protocol, then stop and wait protocol to stop and wait ARQ, and thereafter from stop and wait ARQ we are proceeding towards go back in, and from go back in we are going to the selective repeat technique, so that you need to understand how the journey was, how it was migrated from the noiseless channel to noisy channel. Now the second method is stop and wait protocol. So this frame 0 sent, frame 0 received, and acknowledgement. It was as good as open loop system, but here some closed loop is added. That is, whatever frame is received, for that the acknowledgement is sent. So frame 0 send, frame 0 received, acknowledgement. Then frame 1 send, frame 1 received, acknowledgement. Frame 2 send, frame 2 received, acknowledgement. So acknowledging that the frame which you have transmitted is received successfully by the receiver. So this is what stop and wait protocol. Okay. Next, third technique is stop and wait ARQ. So what is happening? Frame 0, this is sender, this is receiver. Frame 0 send, frame 0 receive, frame acknowledgement 1. Okay. Frame 0 send, frame 0 received, ACK 1. ACK 1 indicates you send frame 1. So this ACK number indicates the frame of next which the receiver is expecting from the sender. See this, frame 0 sent, frame 0 received, ACK 1. So 1 is indicating send frame 1. So frame 1 will be sent by the sender. So frame 1 send, frame 1 receive, ACK 2. So 2 indicates send frame 2. So frame 2 send, frame 2 receive, ACK 3 indicates send frame 3. Frame 3 send, frame 3 receive. So here there is a problem in communication channel. So the frame 3 was sent by sender, but because of network congestion, it could not reach to the receiver. So there is a wastage of time because the receiver is waiting, not doing anything. And unless and until you give that acknowledgement, transmitter will also not send anything. So it will wait for some time. This waiting period, timeout period, is decided by sender and receiver with the separate collaboration. So frame 3 will be sent again. So when the frame 3 will be sent, it will be received successfully. Then receiver will give ACK4. ACK4 indicates that frame 3 is received successfully, which was not initially because of network congestion. So we were waiting for that. That is what the message of this receiver by giving ACK4. So frame 3 will be sent by sender. So frame 3 sent, frame 3 received, and ACK4. ACK4 indicates send the frame 4. So frame 4 send, frame 4 receive, ACK5. So receiver has received frame 4 and sent ACK5, but still it is not received by the transmitter. Then there will be a timeout, time interval for which this will wait, sender will wait. So if ACK5 is not received, acknowledgement is not received, so sender is going to waste. There will be a wastage of time over here. Again, it will waste. There will be wastage of time. So what is the procedure? Transmitter will send frame 4 again. So this is the repetition of 4. So it is a duty of a receiver. It is a duty of a receiver to delete this frame 4. But the receiver will send ACK5 again. So the moment ACK5 is reached to the sender, then sender will understand that frame 4 was already received. But because of this ACK5 not received, it went into waiting mode. But now, after some time, sender tried for that and it sent frame 4. So frame 4 sent, frame 4 received, ACK5. So the moment ACK5 is received, by the transmitter, it sends frame 5 further. So if you see, if there is a loss of frame because of network congestion, it's a wastage of time. If it is a loss of acknowledgement because of any reason, let us say network congestion, there is a waste of time. Again, repeating these frames because it was waiting for this ACK file. Again, there is a wastage of frame. So this is called as non-implementation of pipelining process. So pipelining process in this stop and wait ARQ is missing, because of which the process of data communication, the speed of data communication is going to be reduced, and that we don't want in our data communication. It has to be increased. Slow speed of data is not going to be useful in the today's network communication. Okay, so did you get this? So what we have seen, Just recall it. Okay, ARQ techniques classified in two part: noiseless, noisy. For noiseless, simplest and stop in what protocol we have seen, and for noisy channel, there are three methods: stop in with ARQ, go back in, and selective repeat. So one by one we will go. So this is what simplest method: send, receive, open loop, send, receive, act. Some type portion of closed loop is added. So at least acknowledgement is there in stop and wait ARQ. Then third method, what we have seen, stop and wait ARQ, in which frame is sent, frame is received, and act. Act indicates next frame it is expected. So what is the problem with the stop and wait ARQ? There is a wastage of time if the frame is lost. If there is a wastage of time, if acknowledgement is lost, and there will be a wastage of time in sending these repeated frames. To avoid that, a pipelining to increase the speed of communication, pipelining is implemented. So what is this pipelining? See, drawback of the previous method, just now we saw. Pipelining is not implemented, hence efficiency of communication is less. What is pipelining? In networking and in other areas, a task is often begun before the previous task is ended. This is known as pipelining. Though acknowledgement is lost, other packet should be sent. Sender should not wait for that acknowledgement. Is it clear to you? That is what the meaning is. In stop and wait ARQ, sender need to wait for a frame to reach destination and to be acknowledged before the next frame can be sent. So there will be a wastage of time and wastage of bandwidth in that duration. The several frames can be sent before we receive news about previous frames. This is implemented in the following techniques, and those techniques are nothing but go back in ARQ and selective repeat ARQ. So one by one we will see what is go back in ARQ and selective repeat ARQ. Now all of you give attention. These are the two figures which are drawn for go back in and selective repeat ARQ. Now give attention. This upper portion, this figure, okay, it indicates a go back in technique, and a lower portion indicates a selective repeat technique. Okay, so what is this? A go back in and a selective repeat. In go back in, what is happening? See, these are the different frame numbers by sender. This is transmitter 0, 1, 2, 3, 4, 5, 6, 7, 8, and this is the receiver RX 0, 1, 2, 3, 4, 5, 6. 0 frame send, 0 frame receive, 1 first frame send, first frame receive, second frame send, second frame receive, third frame send, third frame receive, fourth frame send, fourth frame receive. Likewise, eighth frame send, eighth frame receive. Though all the frames are received, let us say here the error is occurred because of network congestion. Let us say error has occurred over here. So what is going to happen in go back end technique? The go back end technique processes like this. If the error is occurred, wherever error is occurred, from that entire frames are discarded by the data link layer. So what is happening? Though other frames are received and only one frame error is there, okay, from that wherever error has occurred, all the frames are discarded. So it is a loss, and there is a wastage of time and bandwidth. Okay, and when again this second frame sent, second frame received, here second frame sent, second frame received, then again this discarded frame, frame 3 sent, frame 3 received, frame 4 sent, frame 4 received, frame 5 sent, frame 5 received, like frame 8 sent, frame 8 received. So whatever frames which were discarded because of this errored frame, from that it is retransmitted again. That's why it is called as go back n. N indicates go back to a nth frame where the error was occurred. That's why this technique is named after this go back n. So n indicates the nth frame where the error has occurred. Go to that frame and send all the frames again so that it can be buffered and processed further. This is what go back in, but there is a wastage of time and bandwidth because of this discarding process of frame. Please keep this in your mind. Next, selective repeat. Okay, selective repeat. So what is the difference between this selective repeat and a go back n technique? See, this selective repeat, multiple frames are being sent at a time, but if error occurs, then what happens? See this, 0 frame sent, 0 received, 1 frame sent, 1 received, second frame sent, second frame sent, second frame is not received, but third sent received, fourth sent received, fifth, sixth, seventh, eighth sent received. So these frames, okay, these frames are not discarded. Please keep this in your mind. In go back in, wherever error was occurred, all these frames were discarded and fresh copy of the frames go back n. From nth frame, it was received and processed further. But here in selective repeat, wherever error has occurred, okay, whatever thereafter the frames were received, they processed sequentially. Further frames were not discarded, were buffered by the data link layer, and they were processed. And wherever error was occurred, that selective frame was requested for that, and that selective frame is received by the sender, received by the receiver from the sender. Please keep this in your mind. So go back and wherever error occurred, thereafter the frames were discarded and fresh frame, entire frames from that go back n number, it is received and processed further in go back n. Whereas in selective repeat, received frames are buffered and processed further, and wherever error has occurred, that selective number is requested to transmit again. That selective frame is received by receiver from sender. Okay, it is received, and already these frames were processed. So this is called as pipelining. And because of this selective repeat request, the request is sent for that selective, or this request is repeated for that selective frame only. That's why the entire process become faster. So there is no wastage of time and there is no wastage of bandwidth. So this is what the advantage of this selective repeat technique. So now you must have understood what we have covered in today's session. So once again, I'm just repeating it. As far as ISO SI reference model is concerned in your syllabus, okay, two layers are included in your syllabus, that is physical layer and data link layer. That too, data link layer is divided into two parts. What is that? LLC and MAC, and LLC is included in your syllabus. So LLC is nothing but logic link control. So what are the function of logic link control? Framing, flow control, data error detection and correction. So framing, as I told you, character count, fixed size framing, and variable size framing. So fixed size framing and character count is not there in your syllabus, and we have variable size framing in our syllabus. So variable size framing is divided into two parts. One is character oriented protocol, another is bit oriented protocol. So these protocols, they use character stuffing and bit stuffing technique. So we have seen both the techniques, character stuffing and bit stuffing, that how bit stuffing is useful. And thereafter, two functions, the other functions of logic link control is data error detection and correction, and flow control. So flow control, we have seen that if a high speed processor is there and a low speed processor is there, and if you don't establish a flow control between them, then what is going to happen? A high speed processor is going to overwhelm the data. Okay, it is going to dump the data to the receiver, and the receiver will be overwhelmed because of this high speed dumping from high speed processor. If you don't install and configure or don't provide flow control process, that's why you have to incorporate the flow control process. And because of, if you don't install it, the errors are occurred, and to avoid these errors, okay, you have to go for data error detection and correction mechanism. So, so entire channel, so data error detection correction. So there are two types: FEC, forward error correction, and another is ARQ. So as I told you, FEC, forward error correction, first 4 unit in our syllabus we have seen. FEC deals with one to all, such type of one to all, that is broadcasting, such type of digital communication broadcast and so on. There this FEC channel error detection and correction technique is used. There is no reverse way. Okay, one way, one to all. So FEC is useful there. And second is a data communication. Data communication is always in the form of request and response. It's a two-way communication. And if the two-way communication is there, then ARQ technique, that is automatic repeat request, ARQ techniques are useful for such type of communication. So these techniques are classified in two forms. What are those two forms? One is noiseless channel and another is noisy channel. For noiseless channel, we have already seen what are the techniques: simplest protocol and stop and wait protocol. And for a noisy channel, stop and wait ARQ, go back and selective repeat. So these are the three techniques. So this is what framing, flow control, data error detection and correction mechanism for this logic link control. So now today we will conclude this session over here, and thus we have covered your LLC part of your syllabus. If you have any question, you please ask me. If you don't have any question, or you can mail me, you can do WhatsApp to me, you can directly call me on my phone. Okay, Google Classroom, all the assignments and all these things are already given to you. If you have any query, through that also you can communicate with me. I'll be available for you till your examination. So after examination also, if you require any help, I'll be there. But if you need any help regarding this, you please ask me. Okay, now today we will conclude this session, and if you have any query, you can directly communicate with me. Thank you for attending and listening this session with the patience. Thank you. Thank you very much.